Hello everyone, my name is Hongjin, and the naming and presentation a paper named Bare Meta Extension for Multi-Tenant Low-Latency Storage. This technology is aimed to improve the performance of our server. Nowadays, as the network grows bigger and bigger, our server need more capacity to deal with large request in a flash time. There has already existed a technology named kernel bypass. Let me introduce what's kernel bypass to you. In our operating system, traditional operating system, if the application want to access CPU or I/O or these hardwares, you need to invoke the system API provided by the operating system kernel. So when it calls the APIs, the kernel will switch the application from user model into the kernel model, so it can interact with the hard devices. And after you use the hard devices, the kernel will switch the application from kernel model back to user model. So scientists find this is the bottleneck of the latency. So kernel bypass is the technology to link user space directly with the hardware, so we can skip the kernel, skip the operating system. It can of our server. So however, in this paper, the author talked the problems of the kernel bypass. When the scale of the data is bigger and bigger, and some applications need to use complicated data structures to help deal with data. For example, Facebook mentioned the tau data structure, and to be simple, we see if there is tree data structure, binary tree. If a client send a GET and put a request to the server need to search the binary tree. And in this example, a tree with n node using gates, and one gate at each level of the tree will cost O log n RTD times. And when server is doing this, the client is stalled, so it will also influence the control flow. And the extra runtime trips will also hurt the latency and alternation. So the author introduced the Splinter. It's a low latency key value store. So tenants can install and invoke extensions at runtime. And the extension is written in Rust language. The extension, let me introduce to you the workflow first. Yeah. So first, before the user use the Splinter, the user can customize its own extension, and the extension is written in Rust language. So you see, you can have your own extension and push into the server. The server will compile and load the extensions into the address spaces. And after you are done with that, you can use the Splinter you send the request to the server, and the network card of the server received your request, and the network card will dispatch the request to multiple cores. And every course there is the user level task scheduler, and the scheduler will invoke the extensions you put it previously at the local storage. So the whole process is done in user level. There is no switch between kernel or kernel model and user model, so it will have lower latency than traditional way. And there is some key points that this technology can have better latency. The first is it uses the flow director that can still work from peer cores. In my understanding, that means there is multiple cores, and if one core has a few tasks and another core has a lot of tasks, and the fewer one will steal some work from the another one, and it will balance the length of the queue, so it will have a higher utilization of the cores. And second, in every single course, the user use the author use the algorithm like CPU scheduling. It's remaining time first. It's shortest remaining time first priority. So that's if one task come first, even if it's having the CPU burst, but if another task comes and with later remaining time, so the scheduler will send the second request to have the CPU burst first. So this solved a problem that non-running task can stop shorter task. And there is another problem. If you switch from tasks, it will cost time. So the user designed a data structure, two structures, that coroutine and task queue. With this structure, it helps single core to switch tasks, and the switch time it just cost 10 nanoseconds. It's a very good performance. Secure problem with when you switch tasks. In traditional ways, it's expensive to store multiple tasks. Big cost, and it's also expensive for latency. But in this data structure, it also solves these problems. And in conclusion, this technology is a better version of kernel bypass. The author used this technology to cooperate with Facebook's style, and it gets a better performance. Thank you.